I would like you to have a picture in your mind of how data modeling strategies are organized. We have unsupervised type algorithms that are useful for finding relationships and data on specified relationships. We have a market basket type data modeling strategies, also known as association strategies, where we are trying to analyze what goes together, that is, what products did a customer purchase all at one time. We also have supervised learning techniques, whether they're estimation, classification, or prediction. The supervised learning process, you must first assemble your data. Then you must present your data to the supervised learning algorithm. Then you must execute the algorithm. Then you must evaluate the model. This is extremely important because all models may not be useful or accurate. Once you are satisfied that the model produced by your data algorithm is accurate and does what you want it to do, then use the model to classify, estimate, predict based on new data. This is where the value comes in. You are able to incorporate that new information produced by the model into your business processes, into your targeted marketing, into your financial forecasts, and so forth. We are going to examine each of these steps in the subsequent slides. This slide shows in graphical format how supervised learning might processed. First, we have our training data. We need to assemble that data. That data is presented to the supervised learning algorithm, and out of that algorithm comes a model. That our model might also be known as a concept definition. Once we have our model, it's important to evaluate that model, to test it. So we present test data to the model. That is almost like testing new software. Once we present the test data to the model will give us some evaluative information, some statistics, some numbers to see how correct was it or how accurate was it. Both the test data and the training data contains in some sense the answers to what we wanted to predict. Once we are satisfied that our model is sufficiently accurate, we can then present unknown data to the model. Data that hasn't previously been classified, data that doesn't contain the answers. We present that to the model. We get new classification, new determinations based on the model. And these determinations will then, if they are able to make any good thing, we can incorporate into our business processes. We said that the first step in the supervised learning process was to assemble our data. We want to talk a little bit about what our data looks like. Our data typically would be a set of rows, each row representing an instance or a case, just like a relational database or perhaps even an Excel spreadsheet. Then the rows might represent customers, they might represent patients' orders, they might represent the entities that we wanted to analyze. The columns of the data represent attributes about these entities. They are values that describe the data instances. Attributes can be input attributes. Those are also known as independent variables. These attributes represent the information we know about the instances. The output attributes, also known as dependent variables, represent the information that we would like our model to determine. Here is an example, a dataset that can be used in supervised learning. Notice that the input attributes are noted in blue. So we have patients. Patients are the instances. Each row represents one instance, one patient. The attributes that we know about the patient are whether they have a sore throat, whether they have fever, whether they have swollen glands, whether they have congestion, and whether they have a headache. We also have over here the output attribute. The diagnosis, that is what we would like our model to predict. We'd like to know whether the patient has strep throat, allergy, or cold. Notice that here the values for the output attributes are already designated. Eventually, we want our model to predict the diagnosis. But for the training data, we must give the model the answers to the diagnosis so it can build up a model that's used for the future. Once we have our training data assembled, we present it to the supervised learning algorithm. As the slide mentions, the data that we present with the answers with the diagnosis filled in. That's known as training data. In the training data, again, the output or predicted attributes must have the values. Then we build the model. We execute the supervised learning algorithm. It's important to understand that the output of that is the model. The model may be specified in a variety of ways. It may be a decision trees, it may be a set of production rules, it may be a mathematical equation. If it is a decision tree, the non-terminal nodes are really the questions they represent the tasks, and the terminal nodes, those are at the bottom, are representative of the outcomes. I think this becomes clear if we look at an example here. Swollen glands should probably be followed by a question mark. This is a question: what does a patient have, swollen glands or not? If the patient has swollen glands, that is, if the value is yes, then the diagnosis is strep throat. That's the terminal node. Another way of defining a data model is using production rules. Production rules are of the form if-then. If antecedent conditions, then consequent conditions. So for example, if swollen glands equal yes, antecedent condition, then diagnosis equals strep throat, consequent condition. Another way of defining a data model is using a mathematical equation. For example, here is a very simple equation that relates customer income to customer purchases. Evaluating is very important. You really want to know whether the model is good. Is it good at predicting what you want it to predict? So the steps in evaluating the model include presenting another set of data to the model. This is known as the test data. Sometimes the test data is the same as training data, but not always. We use the test data we presented to the model, and we let the model predict or classify the test data. Then we see how well it did as compared to the real values for dependent variables. The final step in the supervised learning algorithm is to actually use the model. We put it into production to make its decisions. And again, this is when our business process benefits from more accurate information, from new information, new ideas about how we can do our targeted marketing or financial predictions. This is an example of data that could be presented to the model that's already been developed. And the point I want to make here is that at this point, the output attribute, the diagnosis is not filled in. We don't know the diagnosis is for these patients, and we would like you to use our model to make that prediction. So supervised learning, it could be used for classification, just like the patient diagnosis example before. We can use it to do the estimation. The output attribute is numerical, like the company's revenue, and we can also use it to do the prediction. It depends upon interaction of the data. We have already talked about decision trees as being a model, the way of recording a model, and those types of a model are produced by decision tree algorithms. These are very frequently used type of algorithms used for predicting categorical attributes. Although more sophisticated decision tree algorithm can be used to handle numerical estimations as well. Prediction rule generators is another type of algorithm, although it's very similar to decision trees. Another supervised learning algorithm is a neural network algorithm. It should be noted, however, that neural network algorithms can also be used for unsupervised learning. Neural networks create models that are intended to be like models created within human brain. These models are useful when the input attributes are numeric. However, the shortcoming of this type of algorithm is that it doesn't really give us an explanation of what has been learned. It's not easy for the human to interpret this type of algorithm out as compared with, say, a decision tree or prediction rules. This display shows a graphical representation of a neural network. Regression statistical techniques are still other ways or other algorithms that can create results. In statistical regression, a set of numerical data is related by a mathematical equation, and certainly linear regression is one of those most popular ways. So, for supervised learning techniques, we have a wide variety of algorithms that can be used in data modeling field, including decision trees, neural network, and regression.